Hi, everyone. My name is Dave Duggal. I'm the founder and CEO of Enterprise Web. Really excited to be presenting to you today. I know there's a lot of good speakers, and hopefully you'll find our presentation relevant and compelling. So the topic is BizDevOps. I wrote up originally as aligning the business and IT with graphs, but I think, of course, with graphs, it's more appropriate to say linking the business and IT with graphs. And we're going to present how our utilization of graphs and what motivates us and the capabilities and affordances that we offer. So first, let me set this up in a nutshell. Enterprise Web is a cloud-native integration platform, iPaaS. So we're not a graph knowledge base. We have one. We incorporate a graph knowledge base. It is a part of our overall solution, but we would describe ourselves as a cloud-native integration, really a cloud-native integration and automation platform. So the iPaaS category has been broadly conceived as sort of incorporating a lot of message-oriented middleware in a new modern cloud-native context. So Enterprise Web is an integration platform. And the point of Enterprise Web and why it's relevant to the graph communities is to radically simplify data-centric, event-driven distributed application design, deployment, and management. And if anybody's worked in that domain of, working with all the various cloud-native tool chains, Kafka and, Amazon Lambda and other tools in the space, they would know that this requires heavy engineering. These things are difficult even for advanced engineers, working through issues like concurrency, asynchrony concurrency, immutability, idempotence. These things are very challenging for even the best engineers. It's challenging to do, and it's usually done on a one-off application basis. So we're offering a platform that makes event-driven applications, model-based event-driven applications, easier to do, right? And it leverages, as I mentioned, a real-time graph-connected operational model. And I think that's really an important difference to call out right away. We're talking about an operational model. We don't call ourselves, we're not doing knowledge apps per se, right? We use a knowledge graph. We connect that to graph objects in a business domain, an application domain, and we use that to essentially create a context-aware information system, right? So that we can control the whole system through shared domain semantics and metadata, but the intent, the motivation, the use is for business applications. And the idea, as any of you working in the enterprise or in large organizations know, is that organizations are becoming increasingly fragmented, and creating an umbrella abstraction over the top of their distributed, diverse, dynamic IT environments is usually helpful to them. We have customers in life sciences and telecom, won awards in IoT, et cetera. So we've done this in a variety of domains. So it's a generalized platform for distributed applications. So I saw this. I know the EKGF presented previously and ran a panel talk the other day. And I saw this on their website, and I hope they don't mind that I put it here with the link and all the proper representation here. And I have to say I completely agree with their maturity model. The only thing I would say is that what they say is going to be available in 2027 is actually available today. We enable this sort of graph-connected environment, real-time graph-connected environment today, and that's, again, bridging that sort of knowledge data and application data with the intent of enabling the digital business. So, as to the digital business, almost it's a very vague term, just like agile and all these other terms used in the IT industry, and it's been elusive. 80% of businesses want it, yet 51% of developers and architects that work on doing digital business transformation say they want another job. That's a pretty astounding statistic. That's from November 19th of this year, so a week or so ago. That half of developers tasked with actually realizing and achieving this digital business are going crazy. They need help. They need better abstractions. They need better tooling to make their job easy. One of the problems here I'm pointing out, and I want to make sure I realize many of you are focused on graphs and and some of you, I'm sure, are on the operational domain and the application domain. Many of you are more doing research and knowledge graphs and knowledge applications, data science. So I'm trying to give some background here. So one of the challenges here, if you see in the background of this slide, actually, that diagram is the Cloud Native Computing Foundation's landscape diagram of their vendors. That's what they expect people to deploy, and it's pretty insane. By the time you're done integrating all those tools, you actually have a static siloed solution that's going to be super brittle. Essentially, it's almost like recreating the old middleware stack. So businesses need to rationalize solution architecture to bring order to the increasingly fragmented operations. And of course, our solutions, this is the problem space, and our solution space, which I'm going to focus on, is graph. So there are too many tools and silos, and too little interoperability and automation. So IT needs a practical approach which abstracts away this distributed systems complexity. It's just too darn hard, right? It's engineering, it's architecture, it's computer science, it's state management, it's reliable messaging. This is hard stuff. And so the solution is an enterprise web, a real-time graph-connected operational model where we take the business concepts, types, and policies that define a business architecture or a business at large, and we give it to customers out of the box. We have essentially a generalized graph domain, so you're not building this from scratch every time. We provide a ready-to-use model that includes all the sort of cloud-native concepts, all the distributed systems concepts. You might call them 12. Some people who work in that space would call it 12-factor. All these concepts related to working with things like Kubernetes and working with events and working with messaging. That's all included in the system, as are generalized enterprise concepts, people tables, security, authorization, organizational units, all the base concepts that you would need to start modeling your organization already included. And you could then import your own models. So whether you have an RDF model, a UML model, XML, or JSON, one of the world's largest telecoms gave us a JSON file that represented their information model. We uploaded it, did entity extraction, algorithmic mapping, and we brought it into our graph in seconds. And these are very big organizations with very complex graphs, and we're making that graph tractable and transparent for them, something they can easily see and manage. And then that graph in enterprise web, the notion of the enterprise web is we don't stop at the upper ontology. We don't stop at the knowledge graph. We actually then model all solution elements, or essentially mappings, to these concepts, types, and policies. And when I say all solution elements, I mean not just data access, right? This is not just a simple little GraphQL toy. We're talking about something that is actually going to take complex applications like a Cisco router or an AWS Amazon Web Services endpoint, or a business process, or some other complex artifact, or an IoT, physical IoT device, and model those almost like digital twins using these concepts. And then we're going to give the customers, or they're gaining, global transparency and virtually centralized management, because despite the fact that all the connected elements might truly be heterogeneous and they might be distributed, we're making them look as if they are the same. We're making them appear as if they're all local. And we have these representations of them, these proxies, as it were, these digital twins, which they can then use to manage and configure with metadata. And it becomes then a single source of truth, because we're actually, because these are software objects, mutable software objects, we're actually logging all their state as well. So we actually have the state of all of these objects too. So we can then use them in processes. And because we're bringing this all with graph, it's giving us BizDevOps, which was the subject, the title of the talk, right? Is an upper ontology, a knowledge graph to model your organizational concepts and technical concepts, right? So systems concepts and enterprise concepts. And then a logical space where you're mapping all of your solution elements. And then the physical space, the ops, Well, at some point, these all hit the road, right? They're all residing on databases, or they're all residing in systems or physical devices somewhere. And all those things have to be, you have to have access, you have to do certs and auths, connect to things, integrate with things, you have to manage networking. There's a lot of complexity that takes to make that all easy. To make things simple is very complex, right? Making very distributed systems simple is a very complex task. It requires high-level abstractions and high-level programmability. So with this graph, we essentially get OODA loops. Many of you probably are familiar with this concept, the observe, orient, decide, and act, right? Because we have this, because we're a system, an event-driven system, you can think of us as a cloud-native, complex event-driven system. We're going to observe events in our space, things that we're connected to. We're going to then interpret events against this graph operational model, right? And then we're going to make, we're going to translate policies using metadata and relationships to make decisions. And then we're going to take actions. Those actions are going to be context enhanced. And they're always going to be real time because it's an event-driven system. Everything is happening in real time. And the system is managing the consistency, transactional integrity, etc. And when we say take action, we're not just talking about integration. We're talking about integration, orchestration, automation, and human tasks. So in a single click or a single event, we might be actually doing 1,000 separate operations, translating objects, connecting things, making decisions, and then we might be actually configuring a remote device or a remote function. We might be reporting through the UI to a user, and that's all happening in real time. So that's autonomic control loops using graphs. So the scope of graph here is different then, right? We're not just talking data and functions. We're not just talking about data, but we're talking about data and functions, not just properties, but properties and behaviors, metadata and state, queries and commands, right? We're controlling things. Graph objects and graph processes, right? So we have our objects are DAGs, directed acyclic graphs, and our processes are directed acyclic graphs, right? So everything is graph in enterprise web, and that gives us some tremendous computational power.
Dave, you're at the halfway point.
Perfect. Data integration and service orchestration, graph transaction processing, and cloud-native deployment. So we're literally using graphs to support, for one of the world's largest telecoms, we're actually doing hybrid multi-cloud support, right? Where they're actually using enterprise web, onboarding really complex solution elements that actually support things like this, like this webinar, the underlying technologies that support it, doing that in 4G and 5G, and doing it in a hybrid multi-cloud way where their customers don't know where their service is running. They could actually, it could run in AWS or Google or in the telecom's own cloud or in Microsoft or in IBM's cloud. And the system is handling all the complexity of mitigating the protocols, the formats, and even the service distinctions, configuration distinctions between those environments. So, so again, high-level abstractions to enable high-level programmability. So picking that back down to brass tacks. In enterprise web, everything is graph object. I mentioned that. All graph objects are mapping to a common ontology, types, concepts, and policies. I mentioned that. And they're persisted as loosely coupled, immutable, typed, self-describing software objects with REST interfaces. Right? That's nice, right? This is a very rich object with rich types. These are not simple objects and simple types. They're not, and the types are programmable as well and extensible. So these are not, hard-coded types. This is a system where even the types are actually graph objects themselves, and all the typing is dynamic typing. So, and we're making those complex things again as simple as possible. All of these objects, because everything is an object in enterprise web, that's an isomorphism. So that gives us common objects, give us common methods. That gives us common controls of these objects. Because all these objects look the same to the system, we can apply common policy management to all these objects. They're common governance, common security, common policy management. They're all indexed the same way. They're all tagged the same way. They're all version controlled the same way. And all of that is extracted from the user. If you want to know, if you want to see how it's done, it's visible to the system owner, but it's hidden because at some level, the person at the business application level, the business user doesn't care. The business user just wants a reliable system. So when we're onboarding things, or importing models, or onboarding code packages, or authoring adapters for components, it's all the same approach in Enterprise Web. Because essentially, it's all going to be through a modeling environment. It's going to be through a REST API or a JSON-based portal. And essentially, we're going to create an object template, and that's going to interact with our type system. And the type system is going to interact with the upper ontology. The upper ontology is going to validate the object. It's going to, between the type system and the domain concepts, it's going to apply validations. And then it's going to attach entities and implementations to it automatically. So these are typed objects, regardless of what the object is. I can import a Word document, and Enterprise Web will automatically introspect that Word document, do the entity extraction, do the algorithmic mapping. Same thing for RDF, UML, XML, or JSON. But it's the same thing also if you give me a code package, right? So if you give me, a function, an app business application, I can import that application the same way. I can take that code package the same way, index it, tag it, etc. And I can even allow you to, we can even enable you to author adapters or things, complex other system components. So it's, as I mentioned, it's an iPaaS, it's an integration platform. So it's built for extension. It's built to be open. So even though the system is very comprehensive, it's not a closed system. It's completely open and can work in a very federated manner. The system will generate properties, autofill parameters. It will also generate full-blown interfaces. And we're not talking about Swagger to the extent that people are familiar with that, which just creates stubs and then you still manually integrate that. Enterprise Web creates underspecified interfaces and then does all the bindings at runtime based on context. It manages all of that for you. So it's a very interactive process. All of the objects then are persisted in a cloud-native backing store and as immutable objects. And this method of doing this is essentially a model-driven process itself using the same system technology. It supports version control as well, so you can pass through your updates and upgrades, and it will version all of this in our system. We wrap all of our objects in software contracts, which provides hooks for security, governance, and compliance policies. So, I'm sure I'll get a lot of interesting questions in the Q&A. I know I'm moving very quickly, but I really want to express sort of the breadth and richness of our system to you. But the idea, again, is we're trying to give a system that is both easy to use, but also is responsible and reliable, right, out of the box. Enterprise Web deploys literally in minutes as a cloud-native platform itself. It's very lightweight. It's completely distributable. And we want customers to get value quickly. So we're providing all of these things, and we're enabling them to then build out their solutions. Objects, these objects that are wrapped in contracts can then be declaratively composed, right? Once you onboard an object, it goes to that, it's persisted in a catalog. Then you can go to a catalog, point and click in the catalog, or make references to the catalog, and the system will handle all of the integration for you. Whether you're composing services, tasks, or aggregates. Again, see that sort of the notion, crossing the boundaries between the data space and the application space. The system is going to handle both of those for you. No manual integration. The system does all the binding. Likewise, a process is just another object in Enterprise Web. It's just another DAG object, a directed acyclic graph object, with a set of loosely coupled tasks bound by conditions. So the physics of Enterprise Web, the logic of Enterprise Web, it creates something called homoiconicity, right? Is that objects and transitions are the same thing in Enterprise Web. It gives us this unified theory, a unified theory of types that allows us to, again, get a lot of process optimizations. Tasks are all connected by conditional links, and it's all event-driven, asynchronous and concurrent. Right, so really high performance and scalable. So the functionality that Enterprise Web is, I just described how we model processes as graphs, and customers can actually create other processes and essentially be creating new capabilities in Enterprise Web. But we essentially give you out of the box all the sort of message-oriented middleware, the common message-oriented middleware capabilities, but they're implemented as serverless functions. They're all called on demand and hydrated by the graph. Again, that makes the system very lightweight, very efficient, very scalable. And the graph is essentially in control of the services. Right? So we have stateless serverless functions and a stateful graph. This graph actually is hydrating these services on demand. So it's following all the tenets of cloud-native computing. And we maintain all the scalability, resilience, durability, portability of cloud-native computing while creating high-efficiency, information system. And this is what we would look. I'm just about to wrap up my slides here now. This is what we would look at the application as an application, and you could see that we're northbound. We're pointing in REST API or JSON UI to customer systems, portals, analytics, AI, ML. Now think how exciting that is for you guys who are data scientists or working in knowledge graphs. Well, gosh, we're a fact model that you can reliably call on through a JSON UI or REST API, and you could import, if you had the right permissions, you could introspect our graph. You can not only look at our models, you can actually look at the runtime activity. And also then our system could then make calls up to higher level systems, higher level analytic systems for optimizations, for broader evaluations of state. So Enterprise Web, one of the challenges for the whole graph space is, good inference is supported by good facts. So we're a great fact model for great inference models, right? RDF has its use case. Semantic Web has its use case. This is not an either-or situation. Actually, I would say we're really complementary. That is essentially wrapping up the talk. So how much time do I have, Bill?
You got about 2 minutes left on the talk.
Okay, perfect. Actually, I do actually have another slideshow here. So just going more back into theory, right? So some of you are going to be familiar with TOP's lifecycle information model, and this notion of it's again a maturity model, just like the graph knowledge community's maturity model. And generally, most people are stuck down at the level of syntactic technical interoperability. And Enterprise Web is driving people towards dynamic and conceptual interoperability. That's where you really want to be, right? And the way we do that is that we're saying, well, actually, it's all software, right? So we have a conceptual layer, a logical layer, and a physical layer. And all of those really are models in Enterprise Web because we're going to bind actually physical implementations. Those are something, the physical implementations are derived based on interaction context in real time. It's the model space that we preserve and care about, right? So Enterprise Web is actually is using the same data structures, the same graph object construct, the same methods for the conceptual, logical, and physical models. That is an optimization then for how we can process hyper efficiently and use knowledge graphs to actually do real-time applications. And just for fun, what does that really translate to? It's turtles all the way down. Recursive layers of abstraction. BizDevOps. Some of you might be familiar with that saying, turtles all the way down. But the idea is that the universe is on the back of a turtle, and that turtle is standing on top of another turtle, and that turtle is sitting on top of another turtle. And then when the conversation asks for what's holding up that turtle, you're supposed to say, let's change the conversation. But the idea is that's recursive layers of abstraction. My name is Dave Duggal. Here's some article references for you. If you want, I believe this deck will be shared, and hopefully these links will be active. Get the decks. You could, obviously look us up and learn more. or simply contact me, and we'd always be delighted to talk, demonstrate, and we, of course, just love talking about these ideas. We love talking about computer science, and we love talking about graphs. So thank you for your time today. I really look forward to your questions. I'm absolutely sure you guys won't be shy. I know many of you, and I hope you won't be too rough on me.
Well, thank you, Dave. And yes, indeed, you already have a question from the audience here. It's from Jim, who's asking if it's possible to make a distinction between existing, planned, and deprecated assets.
I'm sorry. Oh, yes, absolutely. So everything is an object in enterprise web. All the objects have lifecycle management. All of the concepts in the ontology are objects. They all have lifecycle management. The ontology itself is an object. It's the set of concepts, types, and policies. It is an object, and it is lifecycle managed. So we actually have something called the model manager, and the model manager actually gives you a vehicle for the data scientist or architect that is generally running or owns the business architecture, let's say, to go in there and control and then publish new versions of the model. And so you can call that a design time responsibility if you'd like. And so the graph model is fully open and extensible, introspectable, navigable. So that's a great question, though. So everything is an object. All objects are version controlled. They're all indexed. They're all tagged. They're all searchable. Again, we're working in the life sciences, telecom, and in other general enterprises. Telecom is considered one of the hardest industries to work in. We're in production. They haven't been able to break it. And they've imported their own information models, and they manage it that way. And they've found it very extensible. So, and they use it as an abstraction over other technologies as well. So, great question.
I have one as well, which I think is kind of related. At some point, you mentioned that you treat objects and transitions as the same thing. Would you like to elaborate a little bit on that? Because it's not something. I guess if you have software engineering or technical background, it's not something you can wrap your head easily around. Yeah,
it is. I pointed it out because I think some people will appreciate it. It is a complex concept. If you think about it, the more transformations you have to do in your pipelines, other than let me back up another step. The only thing the business cares about is their logic and the objects they have access to. We'll stop. No one in the business has ever cared about technology. It's a utility for them to do their job. That's it. That doesn't mean technologies isn't important. So in that context, the more transformations, the more complex my tool chains, the more complex my middleware stacks, even a semantic web step, the more connections I have between the things and the more transformations that happen through those pipelines. And yes, you can do optimizations and things, and we're clearly doing lots of transformations. But really what you'd like to do is just do transformations in and transformations out. And you'd like to actually have your system to be as unified as possible, to do as many things as possible under a common model. And so if you can actually have your process models, so there's two things, a couple things. A unified object model gives you common methods. That's a very powerful concept in computer science. So just in general, if I make everything look the same, then I can apply common policies and common controls on it. That's just even if they're heterogeneous underneath, that's an abstraction that gives me lots of power. If I can do that both over objects and I can do it over processes, that's even more power. We had this back in the mainframe, but the mainframe wasn't distributed. The mainframe had this kind of isomorphism, this kind of homoiconicity. But it's just an abstraction. And if you really want to look into it, I'd recommend my friend Milner, who's no longer with us, rest in peace. But we like to think we stand on the shoulders of giants. Strachey, Milner, Malone, many of the greats. We like Fielding, of course. We like Tim Berners-Lee and Deborah McGinnis and Jim Hendler. All those folks. We stand on the shoulders of giants. We're particularly fond of Milner. Milner wrote the ML language. We're very close to those ideas. but his life's work was trying to unify object theory and process theory, and he died not having completed it. He completed it. We created that. He would describe that as abstract rewriting and transition theory. These are very esoteric areas of computer science, but the bottom line is it's what gives us the power to do what we do.
Okay, well, I have a tough choice here. I can ask you a very direct question from Jean, or I can ask you a more complicated question from me. And since time's running out, I'm going to go with a direct question from Jean, who's asking, how much does it cost? And are there several packages with different levels of capabilities and different prices?
So it's actually super easy. It's one price. It's based on your usage. We've partnered with the world's we're about to announce shortly that we've partnered with one of the world's largest cloud providers. It could run on premise. It could run on any cloud of your choice. It could run as a hosted service, and you literally are charged by your CPU or CPU utilization and your number of users. And we've actually made it fairly inexpensive because we want customers to like it, and then we want it to scale. We don't want to put barriers in between them and the sale, and we don't want to put barriers on them scaling it, because what happens with every one of our customers is they tend to start small because they're excited about it, but they want to start small, start on a single use case that maybe is a hard problem, and then they expand the abstraction over more and more use cases to generalize and take advantage of it as a platform. And that's what we want. You don't care if you start literally using it for a single application or single line of business or single use case. It won't cost much to start at all. We generally start giving customers with parties. We generally do pilots anyway. Those are generally at no charge. We host them. We make them available to serious interested parties. So, and all of the objects that you create on top of Enterprise Web are yours. Think of us as just being the enabling technology. If you create objects in Enterprise Web, those are your objects. Everything can be exported as RDF or XML or anything else that you want it to be. So we're not binding you. It's an open system. It's meant to enable. It's not meant to hinder. We really tried, as the company's name is Enterprise Web, we've tried to align our interests with the enterprise interests. Thank you for that question, though. If there's time, I'd love to answer that hard question, too, because I love them.